Welcome to my presentation on Biomass Power Plant. In this presentation, we'll explore on how biomass is used to create electricity. Introduction to biomass. Biomass is a renewable energy source derived from organic matter such as plants, agricultural waste, and even municipal solid waste. As a sustainable alternative to fossil fuels, biomass plays a crucial role in the transition towards a more eco-friendly energy landscape. This comprehensive presentation will explore the various types of biomasses, the process involved in converting into usable energy, the advantages of biomass power plants, as well as the challenges and future perspectives of this renewable energy source. There are various types of biomass, including wood, agricultural residues, animal manure, municipal solid waste, and many more. Each type of biomass offers us different or unique methods of energy generation. First one is wood. This is the most common form of biomass. It includes logs, branches, wood chips, sawdust, and wood pellets. The second one comes here is agricultural residues, such as crop residues such as straw, husks, stalks, and sugarcane residue are commonly used biomass materials. The other types of biomass are animal manure and municipal solid waste. Animal manure. Livestock waste such as cow dung and poultry litter can be used as biomass for energy production through processes like anaerobic digestion. The second one here is municipal solid waste. Household waste, including paper, cardboard, food scraps, and yard waste, can be used as biomass for energy generation through incineration or other processes. Biomass power plants operate on the principle of converting biomass into energy through processes such as combustion, gasification, or anaerobic digestion. These processes produce heat, which is then used to generate electricity. Now, coming to the working principle of biomass power plant. Steam turbine operation. High pressure steam from the boiler spins turbine blades, causing them to rotate. This rotation transfers steam's energy to the turbine rotor, making it spin. Electricity generation. The rotating turbine is connected to an electrical generator. As the turbine spins, it turns the rotor inside the generator, which is surrounded by a magnetic field. The rotation of the rotor inside the generator induces an electrical current in the generator coils through the principle of electromagnetic induction in the form of alternating current used in power grids. Power distribution. Generated electricity, initially high voltage AC, is transmitted through power lines. Before being fed into the power grid, the voltage is usually increased through a transformer to reduce the energy losses during transmission over long distances. The electricity is then transmitted through power lines to substations where the voltage is stepped down to levels suitable for distribution to homes, businesses, and other consumers. Biomass conversion process. Combustion. Biomass is burned to produce heat, which can be used directly or converted into electricity. This heat is used to generate steam, which drives turbines to produce electricity. Next, biomass gasification. Another method is biomass gasification, which converts biomass into gaseous fuel called syngas. Syngas can be used in engines or turbines to generate electricity efficiently. Biomass is heated in a low oxygen environment to produce syngas used for electricity, heat, or as precursor for biofuels and chemicals. Next comes anaerobic digestion. Microorganisms break down organic matter to produce biogas, methane and carbon dioxide, for electricity, heat, or vehicle fuel, along with digestate for fertilizer. Now coming to the advantages of biomass power plants. So there are various advantages of biomass power plants, but the main four are listed in this slide. Coming to number one, renewable and sustainable. Biomass is a renewable energy source and it is continuously replenished. So there is not a point of time where biomass has been banished because you always you always have it in nature. You can always get it and it is always renewable. Number two, carbon neutral. Biomass power avoids additional carbon emissions, and promotes carbon neutrality. Number 3. Waste utilization. Biomass plants utilize organic waste, reducing landfill usage and methane emissions. Coming to number 4. Flexible fuel sources. Now, biomass power plants provide reliable base load or dispatchable power. These are few advantages of biomass power plants. Economic benefits of biomass power. Now that we have discovered the basics, let's explore the economic benefits of biomass power generation, including job creation and revenue generation for farmers and foresters. Number 1. Job creation. Biomass power plants require personnel for various tasks, including operation, maintenance, and administration. Additionally, the supply chain involving biomass collection, transportation, and processing creates employment opportunities in rural areas where biomass resources are abundant. Now, moving on to the second economic benefit, which is revenue generation for farmers and foresters. Biomass power plants provide a market for agricultural residues, wood waste, and energy crops. Farmers and foresters can generate additional income by selling biomass feedstock to power plants. This diversifies their revenue streams and enhances the overall profitability of their operations. Types of biomass power plants. Biomass power plants come in various types, including direct combustion plants, gasification plants, anaerobic digestion plants, and combined heat and power (CHP) plants. Each type has its own advantages and applications. Now let us look into all of these biomass power plants briefly. Number 1. Direct combustion plants burn biomass directly to produce steam, driving turbines for electricity. Number 2. Gasification plants convert biomass into syngas used in engines or turbines for electricity. Number 3. Anaerobic digestion plants use microbes to break down biomass into biogas for electricity or upgrade it to biomethane. Number 4. Combined heat and power (CHP) plants simultaneously generate electricity and heat from biomass, increasing overall efficiency. Now that we have seen the advantages of biomass power plants, let us even look at the challenges and limitations of biogas power plants. Number 1 is technological limitations. Integration into existing infrastructure and grid stability require upgrades and advanced management techniques. Number 2. Feedstock availability. Seasonal and geographical limitations. Competition for biomass and infrastructure needs. Number 3. Transportation. Transporting large volumes of bulky biomass feedstock to power plants can be expensive and energy intensive, particularly in remote or rural areas. Number 4. Environmental concerns. Air pollution from combustion, land use changes, and biodiversity impacts. Now let us conclude the presentation. Biomass represents a versatile and promising renewable energy source that can play a crucial role in the transition towards a more sustainable energy future. By harnessing the power of organic matter, biomass power plants can contribute to reducing greenhouse gas emissions, diverting waste from landfills, and providing a flexible and reliable energy supply. While challenges and limitations exist, ongoing technological advancements, integrated biorefinery concepts, and supportive policies are paving the way for a future where biomass becomes an integral part of diverse and sustainable energy portfolio. Thank you for joining us today to learn about biomass power plants. We hope this presentation has provided valuable insights into the potential of biomass as a renewable energy source.